For decades, humans have searched the vast expanse of the universe for signs of life beyond our planet. Are we finally on the brink of discovering intelligent life? Have we just found evidence of powerful extraterrestrial civilizations? Let's find out. A civilization's energy use determines where it falls on the Kardashev scale. Stephen Hawking once claimed that to his mathematical brain, the numbers alone make thinking about aliens perfectly rational. The real challenge is to determine what aliens might be like. Should we look for germs or little green men? How might we track them down? Are those radio waves or peculiar substances in the planet's atmosphere? Over the years, researchers who have considered the possibility of life existing somewhere other than Earth have wondered what such life might resemble, how we might recognize it from a distance, and whether it might be possible to communicate with it. Kardashev's scale has been mentioned by scientists and writers of science fiction over the years, and both have complimented and criticized the system. This scale has the advantage of concentrating on a civilization's detectability by humans as opposed to its significant technological development, most of which may occur in ways that astronomers cannot witness. However, it has also been criticized for being overly simplistic due to its focus on a single characteristic and its limited number of broad categories. It has also grown more challenging to accept that the scale used to evaluate progress emphasizes ongoing development. Is this the evidence of powerful extraterrestrial civilizations? Ivan Ivanov, a researcher at Harvard University, asserts that the historical predominance of radio astronomers in the SETI field led to the emphasis on radio signals as the primary means of finding extraterrestrial intelligence. He said radio astronomers focused more on large-scale radio observatories because they thought more significant, more powerful telescopes would be better adapted to detecting signals from more advanced civilizations. But as the effects of human exploitation of fossil fuels on the world have become more apparent over time, it is no longer safe to idealize perpetual energy deprivation. The report by Kardashev also touches on the core conflict that still exists in the hunt for extraterrestrial life. Is it more valuable to hunt for techno-signs, such as radio waves, which depend on intelligent life adept in perceptible technology, rather than biosignatures, changes to a planet that only life at a specific size, such as microorganisms or manatees, can cause? Since the dawn of humanity, several notable discoveries suggest the presence of powerful extraterrestrial civilizations. A significant evidence discovered is detecting a strange signal known as the WOW signal. In 1977, astronomer Jerry Ekman was working with Ohio State University's Big Ear radio telescope when he detected a powerful radio signal coming from the direction of the constellation Sagittarius. The sign was so vital that Ekman circled it and wrote "WOW" in the margins of the printout. The signal's origin remains a mystery, leading some to speculate that it could be evidence of an extraterrestrial civilization attempting to communicate with us. On top of that, Tabby's star discovery, also known as KIC 8462852, is also very mysterious. In 2015, astronomers discovered that the star's brightness was fluctuating in an odd and unprecedented way. Some have suggested that these fluctuations could be caused by a massive alien structure, a Dyson sphere designed to harness the star's energy. You all must be wondering what Dyson sphere is. Hold up, we'll clear all your doubts here. A Dyson sphere is an engineering project of stellar proportions. It offers its designers adequate surface area for habitation and the capacity to fully use the solar radiation coming from its central star, making it the ideal choice for both living space and energy generation. The question here is, why would someone create such an odd monstrosity? Well, a British-American theoretical physicist, Freeman Dyson, suggested that an advanced alien society might think about the project after establishing on some moons and planets in their immediate star neighborhood in 1960. These extraterrestrials would start using more energy as their population grew. Dyson's estimates predicted that the aliens' area and energy consumption would rise exponentially, reaching 1 trillion times more significant in just 3,000 years. Assuming that their population and industry grew at a moderate 1% per year. The engineers of the species could attempt to devise a method to disassemble the planet and distribute its mass in a spherical shell if their solar system contained a body the size of Jupiter. The material would be enough to create an enormous number of platforms in orbit that are 6 to 10 feet, 2 to 3 meters thick, allowing the aliens to dwell on their star-facing surface by placing structures at a distance twice that of Earth to the Sun. In the words of Dyson, the structure would eventually need to re-radiate the energy it had captured and used, or else it would accumulate and eventually cause the sphere to melt. Accordingly, Depending on how dense the orbiting platforms were, the light of a star enclosed in a Dyson sphere may appear dimmed or even completely darkened to a distant observer while glowing curiously bright in infrared wavelengths that are invisible to the human eye. With recent technological advancements and our understanding of the universe, the search for extraterrestrial life has become more sophisticated. The vastness of the universe is the primary proof that extraterrestrial life is possible. In the observable universe, there are thought to be billions of galaxies, each with billions of stars, many of which have planets of their own. The likelihood that Earth is the only planet in the cosmos that can sustain life seems exceedingly slim. In fact, according to current research, the number of Earth-like planets in our galaxy alone could reach 6 billion. The finding of extremophiles, or organisms that can endure in harsh settings on Earth like the deep sea, Antarctica, or environments that are acidic or alkaline, is another reason for the potential of alien life. This means that habitats once assumed to be uninhabitable, like on the frozen moons of Jupiter and Saturn, or in the deep oceans of Enceladus and Europa, could support life. Another piece of evidence supporting extraterrestrial life's existence is the discovery of organic molecules within our solar system. The basic blocks of life are organic compounds like amino acids, which have been discovered on comets, asteroids, and even Mars. While the existence of organic molecules does not necessarily imply the reality of life, it does mean that the conditions required for life might be more prevalent than previously believed in the universe. Along with these considerations, new technological developments have bolstered the quest for extraterrestrial life. More in-depth research on exoplanet atmospheres will be possible thanks to the development of solid telescopes, like the James Webb Space Telescope. With the creation of more sensitive instruments and innovative search techniques, the SETI, Search for Extraterrestrial Intelligence effort, has likewise advanced in sophistication. Also, we are still determining what forms of life exist in environments other than Earth, or which conditions would be most favorable for its emergence. Due to the interstellar distances involved, we won't be able to visit other star systems soon. Thus, our hunt for extraterrestrial life will have to rely on distant observations and research. Meanwhile, superintelligent civilization is fundamental here, and you might want to listen to this. As we have already discussed, the Kardashev scale. These civilizations are interlinked with it. Russian astronomer Nikolai Kardashev introduced the idea of a superintelligent society in 1964 to categorize advanced extraterrestrial civilizations based on their capacity for energy consumption. A civilization of Type 1 can utilize all of the energy produced on its own planet, but a civilization of Type 2 can use the whole energy output of its host star. As said, a Type 3 civilization can harness the energy production of the entire galaxy. Consequently, how could a Type 3 civilization reach this energy consumption level? A Dyson sphere is possible, but a Type 3 society may also use other cutting-edge energy harvesting methods beyond our comprehension. It's important to note that neither Type 3 civilizations nor any other extraterrestrial civilizations are supported by direct evidence. However, many scientists and science fiction authors have been fascinated by the concept of a superintelligent civilization and have thoroughly investigated its potential. The possibility of these civilizations' existence raises the question of whether our existing observational techniques would be able to spot them. The massive quantities of waste heat that civilization would likely release into space, if it were able to harness the entire galaxy's energy production, could perhaps be seen by our telescopes. However, the technology needed to detect such detections has yet to be available. Apart from that, whether or not a civilization would be interested in getting in touch with us, it's feasible that if a culture has attained such a high level of technological development, our society might appear very primitive in comparison. Alternatively, they might see us as threats or be unwilling to communicate. Remember to subscribe to our channel for the latest insights from this world and beyond. The prospect of coming across extraterrestrial life forms is still a fascinating wonder as we delve deeper into the vastness of the universe. If you're eager to learn more about alien life forms in our universe, click the video links on your screens to clear all your doubts. And as always, we'll catch you up in the next one. Until then, take care.